So the whole chapter 7 is about how to estimate the parameters and determine the minimum sample size for estimating. The first section we will talk about how to estimate a population proportion. So we will focus on 3 objectives. The first one we will talk about how to point estimate. Then we talk about how to construct the confidence interval. So we construct an interval to estimate the true value. The last topic is we need to find the minimum sample size to help us to do the estimating. So first topic is point estimate. So point estimate is a single value used to estimate a parameter. So it's just the single value. So we call it a point. It's just one value. And we already know 3 important unbiased estimator from last chapter. And one of important unbiased estimate is called p-hat. Remember, it's the sample proportion p-hat. Because this one is an unbiased estimate, so it's the best point estimate of the population proportion p. So we only need to find what's the p-hat to estimate. That is the point estimate. We just use the single value p-hat. So the reason is here because it's the unbiased estimator. Unbiased estimate means the mean of this estimator, mean of all the p-hats, is equal to the population mean, p. So we will say p-hat targets the p, so it's called unbiased. Let's check the example. So in this example, we know some information. We have 1,487 adults, and 43% of them said they have a Facebook page. Based on the information, we want to find the best point estimate of this proportion. So for this point estimator problem, it's very simple. We only need to find one single value to estimate. And we already know for proportion, the best point estimate is just the sample proportion. So it's just the p-hat. We just use the p-hat value to estimate the p. So p-hat value in this case is just this one. Because this is our sample, 1,487 adults is our sample. And from this sample, we know 43% of them. 43% is our sample proportion, is our p-hat, or you can write 0.34. So this is how we find the best point estimate. Again, it's just a single value. For p, it's just the p-hat. So this is how we interpret it. Best point estimate of p, which is the p-hat value. This one is just the p-hat value, 0.43. It's just the 43%. So the most important part is about the confidence interval, because point estimate is just give us a single value. It's not very reliable. We cannot say it's a reliable estimator, but confidence interval is more reliable. We set a range, not a single value. We set a range. Try to estimate the true value. This is called confidence interval, or we will say CI. Confidence interval is in interval, is in range. It's not the single value. Single value called point estimate. But if we talk about confidence interval, we have several concepts. So the first one we call the confidence level. So confidence level is the probability. The confidence interval actually contains the true value. So it's the probability. Actually, this confidence interval actually contains the parameter. And we use 1 minus alpha to represent the confidence level. Or we can also call the degree of confidence coefficient. That's the same meaning. Confidence level. It is just 1 minus alpha. What is alpha? We will talk about it a little bit later. But confidence level is 1 minus alpha. So if alpha is 5%, then confidence level is 95%. So we can set the value of alpha. And we only need to know the relationship between alpha value and the confidence level. So if we set alpha to be 0.1, then the confidence level will be 1 minus 0.1. It will be 0.9 or 90%. Similarly, alpha is equal to 0.05, then the confidence level will be 95%. If we set alpha to be 0.01, we will say the confidence level is 99%. So it's just a relationship between confidence level and alpha value. Alpha value has a name called significance level. Okay, alpha has a name is significance level. So we should know how to interpret a confidence interval. Sometimes the problems give you the confidence interval. You need to understand what does that mean. And we only have one correct way to interpret our confidence interval. Make sure you just use these words, the words in your textbook, to interpret the confidence interval. Do not to be very creative. Don't use your own words. Make sure you use the word. It's the only way to interpret the confidence interval correctly. We will say, if the confidence level is 95%, we will say, we are 95 confident. The interval, the confidence interval, let's say if we have this as our confidence interval, from 0.405 to 0.455, this interval, 95% confident this interval actually contain the true value. So this is the only correct way to interpret the confidence interval. Again, do not use your own word. So let's see, what does 95% mean? If the confidence level is 95%. So let's check this graph to help you understand what does confidence interval mean. We have 20 different samples. Okay, we have 20 different samples. Each sample, we get a confidence interval. For each sample, we use the values in this sample set to get a confidence interval. So we have 20 different samples. We will have 20 confidence intervals. So here, each line, each stick means the confidence interval we have. Total, we have 20 bars, means we have 20 confidence intervals. Then we realize 19 out of 20 confidence intervals contains the true value, 0.5. So this horizontal line tells us the true value of the P is 0.5. We see all of the red bars contains the true value. The green bar does not contain the true value 0.5. We realize 19 out of 20 confidence intervals contains the true value. So which means 19 out of 20, right? We have 19 red bars. Red bars contains the 0.5 true value. The green bar does not contain true value. So 19 out of 20 confidence intervals does contain the true value. 19 over 20 is just 95%. So that's the definition of our confidence level, 95. So we will talk about the critical values again. In chapter 6, we have already learned how to get the critical value Z. I told you critical value is a Z-score, but this Z-score has a special meaning. So let's go back to check the critical value again. Here we have the critical value C sub half alpha, which means Z sub half alpha, this is our Z critical value, right? This Z, we can separate the whole area into two parts. And the right tail is just the half alpha. That's the meaning of critical value. So this is our C sub half alpha. We use this C to separate the whole area into two parts. And the right tail, the area of the right tail is just equal to half alpha. So that's the definition of Z sub half alpha. We can use this. We can use the Z table to find this critical value. Let's check how can we find the critical value here. Let's say if we know the confidence level is 95%. We want to find the Z sub half alpha. If we want to find the Z sub half alpha, we need to know what is the alpha value, right? If we know the alpha value, then we can find the Z sub half alpha. So how can we get the alpha value? Because the question didn't show you what's the alpha value directly. We need to check the condition we have. We have this sentence, 95% confidence level. So confidence level is 95%. But we know if we use the symbol to express the confidence level, we know we can use 1 minus alpha. So if 1 minus alpha is 95%, we know we can get the alpha value is 0.05. It will be 1 minus 95%, 0.05. Of course, if we know alpha value, we can absolutely get the half alpha value. It's 0.025. So this one will be 0.025. Agree? Z sub half alpha will be Z sub 0.025. So if we could sketch a curve, we know this Z is our critical value Z. This Z can separate the whole curve into two parts. And the right tail of the curve, this area, we was know it's just 0.025. Why we can get this value depends on this small number here. It just shows us the right tail area is 0.025. Then next step, how can we get the Z? We have the area. We can get the Z by checking the Z table. But the question is, can we directly use 0.025 to check the z-table? No, of course not, because this time 0.025 is not the area cumulative from left. It's the right tail area. But we always need to get the left side area. So this time we should get the area cumulative from left first. Then we can use that value to check the z-table. So this one just show you how can we get the alpha value. We use the significance level to get the alpha value, because significance level is 1 minus alpha. 1 minus alpha, 95%. The alpha is 0.055%. Then we use half alpha to get the area cumulative to the right. But don't forget, we should use 1 minus 0.025 to get the area cumulative to the left. Now we could check the table. Which part should we check? We should check the body of our z-table. We check the body of the z-table to find which one is closest one. If you can find exactly the same one, that's good. But sometimes we cannot find the exactly same one. We find which one is closest to that value. Then check the left column in the top row to find the z value. If you have your z-table, you realize 1.96 is z sub half alpha. So here is z sub 0.025. Okay, this curve also helps you to check the critical value. So again, this half alpha, z sub half alpha is just the area of the right tail. It's just the area of the right tail. So this table shows you some useful critical values. If the confidence level is 90%, then alpha value is 0.1 and half alpha. So maybe some students have the question, why we should use half alpha to find the critical value, not just z sub alpha, because we should know confidence interval here. 95 confidence interval. It means 95% right in the middle. Or we can say confidence interval always has two tails. So this is the one side. Another side is on the right. So 95 right in the middle. Left tail, we will have half alpha. Left tail, we will have another half alpha. So two tail, we should divide our alpha by 2 to get half alpha. This two part add them up, we will get half alpha. And inside, that's 1 minus alpha. So total area minus the middle part, we will get alpha for two sides, and each side we will get half alpha. So that's why we need to get half alpha, not alpha. And you can memorize this important values. So this will be half alpha will be 0.05. This c sub 0.025. And this one will be 0.005. Remember here is half alpha. See the relationship? Here is alpha. Here is half alpha. So these three are the most commonly used critical values. If possible, please memorize critical values. If you forget it, of course, you can use my way to sketch a curve to help you find that critical value. Of course, here we have a new concept when we talk about confidence interval. We call it margin of error. We call it margin of error. The meaning is the maximum likely amount of the error. So you can also call it the maximum error. We use this capital letter E to denote it. So it's just the maximum error, or we call it margin of error. We will use this value when we try to construct the confidence interval. Now we have the formula of how can we get the maximum error or margin of error. So that's why we need to learn how to get the critical value C sub half alpha first. We need this critical value to calculate the margin of error. So that's the first term in this formula, critical value. So the critical value is extremely important. The second part of the formula we see that in the square root, we have the p hat. Make sure you know this is the proportion, right? This is the sample proportion. And what is the q hat? We always know the relationship between p hat and q hat, remember? The sum of p hat and q hat is equal to 1. And this n is always stands for the sample size. How many values in our sample? So we should know how to construct the interval to estimate the proportion. So point estimate is just single value, so it's not reliable. We prefer to use the interval to estimate the parameter. Let's check the notation. So again, here, the lowercase p is the population proportion. So without the hat, it's the parameter. With the hat, it's the estimator. So it's p hat, sample proportion. N is always sample size. And the capital letter E is the maximum error, also called margin of error. Make sure you understand here the critical value is always C sub half alpha, okay? Because confidence interval has two-sided, two-tailed. So each tail we will have half alpha. Let's check confidence interval. We should check the requirements. So we can quickly go through this part because in your exam or quiz, I've already done this for you. I've already checked all the requirements. And so the simple random sample, of course, all the samples should be simple random sample. And the second rule is the binomial distribution. So we need to check if the distribution is binomial, yes or no. Because remember, the P and the Q, they are always talking about the binomial distribution, right? So make sure the distribution follows a binomial distribution. And we should know at least 5 success or at least 5 failure, which means n times P is greater than or 5 and n times q is greater than or equal to 5. So we already know that's the requirements for binomial distribution too. So we can check how to construct our confidence interval. This is the parameter we want to estimate, right? So point estimate is just the p hat. When we construct our confidence interval, we still need to use the point estimate, but it follows this format. Point estimate minus the margin of error to point estimate plus margin of error. So you can write your confidence interval into this form. This is the first way you can write. And the second way, you can just write it like this. The confidence interval for P is P hat minus E to P hat plus E. This is another way to express it. Okay, so this one is also fine, right? This is the second way. But how can we get the E? We need to use this formula to get the E. Remember the first term, we need to find what is our critical value. After that, we can get our margin of error. The round-off rule is just 3 significant digits. So this is the procedure. Again, we check the requirements first. But in your test, you can quickly skip this one because I will check the requirement. The second one, we need to find the critical value. Second step, find the critical value. Again, here it's half alpha. Z sub half alpha, not alpha. Then step 3, use that critical value to find the margin of error. Step 4, we can write our interval into this form. P hat minus E to P hat plus E, because P hat is the point estimate. Point estimate plus minus margin of error to point estimate plus margin of error. So last step, we just round our answer. Let's check this example.